Yes, very good afternoon to all of you. I am sure I am not going to ask you to write something on the paper. I'll request you to listen the topic on the board, right? And this is unit number 2, bipolar junction transistor. I request those who are sitting at the edge, I'm sure my voice will reach you, and if you really want to have some interaction or stay comfortable, come forward, because there are so many seats are vacant in this place, right? If you really want, come forward. Okay, listen, today I would talk to me myself saying that it's an important class for me to make you to realize the first most effective device called transistor. At the same time, I know there are people who are got absent today, and I'm sure you are more than 75% of attendance. So I'm sure I will repeat the same class in the future, but I'm sure this will give you the pumping force of this particular subject, right? So bipolar junction transistor, it is also called as BJT. At the year, this prominent or this novel device was suggested by John Braden, William Shockley, and listen. So this is a novel device, as I mentioned, right? This was invented by John Bradman and William Shockley and one more guy. I forgot, but the year 1947. At year 1947, exactly December. Okay, so where? At Bell Laboratory. At Bell Laboratory, this is the conceptual understanding, and this is a real device made at Bell Laboratory at the year of 1947, right? In the form of a vacuum tube, right? The first transistor generally vacuum tube type. Then William Shockley proposes a first junction transistor, semiconductor made junction transistor at the year 1951, and he also got Nobel Prize at the year of 1956 for the same, right? So this is again I'm saying 1947, every Indian will remember what is the meaning of that. Again, in science, that too belongs to semiconductor family like us, we never forget 1947, especially at December. Okay, so this year gives a prominent year for science and development. Today we talk about artificial intelligence, talk about robotics, healthcare, e-vehicle, and data science, and some prediction algorithms. There are so many things we talk about them, right? Talk about data sets. But everything is possible because of semiconductor. We proud to be being a part of electronics engineering because we made the sky technology. We made a sky technology, right? That's why we are always taught top of this world, right? So later in the year of 1951, I made a first silicon made, right? First silicon made transistor, and again their types are given NPN and PNP transistor, right? So this is a part of the little glimpsey history of ourselves. Now we move on to the topic. I'm sure this, I'm sure our college day going to come, cultural day going to come. Anybody wants to sing a song? Or anybody had a plan? Say I'm talking. Yes, I am asking you, and don't mention your blah blah X, right? Listen, he may be your friend or enemy, don't mention others. If you really have a word, please sing a song for me today. Because I'm talking about semiconductor, I'm talking about bipolar junction transistor. So now, so mic, right? Mic, what is that? Convert air damp into electrical. Right? Mic is the device where converts air pressure into electrical. What is electrical? I'm sure there is a signal. There is a signal. Right? For example, I sing a song, right? I'm sure I'm not a good singer, but anyway, just assume, or some people will sing a song. The song can be a good song, but ourselves represent. I produce audio signal as in the form of song. Even I could spell Namo Narayana, Om Namo Narayanaya Namaha. That is one of the sentence I spelled. So this look like my audio input look like this, right? By audio. My audio input look like this. My amplitude varies with respect to time, right? This is my input, right? At the end, at the end, at the end, somewhere end, okay, some kilometer or some 500 meter around or some distance, I have a speaker. I have a speaker, look like this. I think every speaker they have some studio KMS, KVV, something, right? You'll find some sticker on that, right? This generally call it as a speaker, right? Generally call it as a speaker. Again, speaker receives some AC signal. So whatever I said here, right? As what I said here as a simple sentence, or I could be a public speaker. I spell something, or a look like song. So I taken from here, and it has been traveled. It has been converted from physical into electrical. There is a transducer. We generally call it as a pressure transducer, where convert your air damped pressure into electrical signal. I'm sure the electric signals are look like this. Time varying quantity. Again, the same will be done here, which will be transmitted over the space, and here I'm listening the same song, right? In another form. What I'm trying to say here, I produce some audio where it can be converted and transmitted some distance. Then same can be reproduced with the amplified. Got the point? Now I have a mic and I have to record all the information which will be amplified. Later you will listen. Look like the mic will convert physical or non-electrical quantity into electrical quantity, and again the speaker will convert electrical quantity into physical quantity, kinetic energy, right? Convert electrical into audio. Then why I couldn't see this current? Let's say this is current, probably AC, this current. I couldn't see. Why? It is all in the form of microampere, all in the form of microamps, milliamps. I couldn't see. Then what I needed to have a amplified version. This could probably, if I shout, I could reach some few desks. For example, if I want to pass my audio signal to somewhere else, to Sriperumbudur or Kanchipuram or somewhere else, then I need a specific device called amplifier. So the amplifier is the device where it converts weak audio signal into strong audio signal. That is one word, right? Now we'll see what I'm going to fill it on the board. We'll see. Again, this transistor, right? This transistor can be utilized in the form of end, right? In the end app, this can handle, this particular device can handle analog, digital. It handles analog and digital signal, and sometimes we could have a mixed signal process. Now we talk about BJT. BJT can be the basic function. It can be a amplifier, right? Amplifier, and sometimes it can be a switching, right? So the amplifiers, I generally call it as analog, and this can be called as digital, right? So the analog will have the amplifier, digital will have the switching. The switching can produce processor, right? Switching can produce processor, microprocessor or microcontroller. So these two are my wider application. Sir, I don't know about what is BJT. Then you talk about these things. This is your question, right? Now I am going to talk about introduction to bipolar junction transistor. Bipolar junction transistor. Remember this word, bi. Why it is bi? Why it is bi? Because it is by means of electron and hole. Polarity, bipolar, plus and minus, right? Junction, we know NPN junction, PNP junction, junction made. I'll tell you why junction. Why junction is necessary at this point. Why then later examination, later classes, I will tell you what are all the problem because of the junction. That we'll see later, right? Later class. Now, bipolar junction made transistor means transferring signal from one port to another port, probably source to load, right? Probably source to load, right? Source to load, transferring signal from lower resistance into high resistance. Why I am talking about lower resistance to high resistance? See, probably everything fall from water, fall from high head to low head. This chalk piece fall from high head to low head, and water, apple fall from tree. Okay. Suppose if I want to transmit the chalk piece from lower height into higher head, then I need to use some force on it. So that's why if I really want to send a signal from lower resistance into high resistance, I need a device called transistor, where transistor pass a signal from low resistance source into high resistance load. These are all the importance about the transistor. Now we'll get into the topic of what is BJT, sir. Okay, now before getting into that, I elaborately convey the information about where he was born at Bell Laboratory. At what year? 1947 December. Then usually he was made by a vacuum tube, right? Vacuum tube followed by junction transistor proposed by William Shockley. Later he got 1956, he got over by two types. Again, the end applications can be analog. Analog, the main application is called amplifier. Then digital, zeros and ones, or processor. And one more, mixed signal processing called analog and digital. It is called signal processing or digital signal processor. Right? Class representation. Okay. Nived, please. Okay, shall we move? Now, I want to fill this area. Now, how this simple transistor can be an amplifier? How this simple sandwich type semiconductor convert weak signal into a strong signal, right? Weak signal into a micro amp or micro volt into PMPO, power modulated power output. Now we'll see one by one. This is overall idea. So why I gave this kind of ideas? Because you need to understand the importance of transistor. Why I'm studying? Why I have to study transistor? What is the importance about transistor? Right now, we'll slowly go. Right now, introduction to the transistor. Transistor. What is diode? It is a PN junction diode. P-type region, N-type region, and we understand what is the meaning of P-type by doping boron. Then we understand what is the meaning of N-type by doping arsenic or phosphorus. Now we are here to discuss about a transistor. As I mentioned in the earlier class, the title is bi, mean two junctions, right? Polar, two charges, right? Bipolar, NPN. Again, I'll tell you later why NPN. I'll tell you later. You could also take PNP for the same, but there is a specific reason. Got the point? There is a specific reason. I'll tell you in the end of the class. You'll ask me why NPN. You remember to ask why NPN. This is basically a three-layer, right? Three-terminal. Yeah. Three-layer, three-terminal device. Three-layer, three-terminal device. I'm sure I'm not a good person. Why? I have not equally divided. Why? You see, this will be very, very thin. See, if I am a good person, I will equally divide the given specific specimen area. But whereas I divide in an unequal manner, where I'm sure there is a reason for that. This first lower area, generally call it as emitter, generally call it as emitter. The capital E represent emitter, the capital B represent base, emitter, base, capital B, capital E, then capital C, capital C represent collector. The title is very clearly says emitter emitting majority carrier, collector collecting majority carrier, base allows the minority carrier. Emitter emitting majority carrier, collector collecting majority carrier, base allows the minority carrier. Now this is the NPN transistor. According to the area wise, who is very strong? According to area, the collector is greater compared to emitter is greater compared to base. According to the area or width, according to area, the collector area is greater compared to emitter, emitter area is greater compared to base. In other words, base is very thin, base is very thin. Then by means of doping, then by means of your emitter is heavily doped. Emitter is heavily doped. HEA, take down. E, emitter is heavily doped. HEAVILY, heavily doped. Emitter is heavily doped. I tell you, this is title Introduction to Bipolar Junction Transistor. Bi represent two junctions. Bipolarity represent the current conduction due to both majority and minority. What is bipolar? Bi represent two junctions. Bipolar represent the current. The current through device is due to both majority and minority. It is a 3-layer, 3-terminal, 2-junction device. It is a 3-layer, 3-terminal, 2-junction device. Three terminals, namely emitter. 3-terminal, namely emitter, comma, capital E stands for, capital E represents emitter, open bracket, heavily doped, and letter C, capital C represent collector, letter C, capital C represent collector, open bracket, moderately doped, moderately moderately doped. Next, letter B stands for base, letter B, capital B stands for base, open bracket, lightly doped, lightly doped. Okay, now, so we know that emitter is heavily doped compared to collector is heavily doped compared to base. Now listen, see, I have started, there is a mic where it converts non-electrical quantity into electrical quantity. There is a speaker that converts electrical quantity into sound, kinetic energy, right? Well, in the end of this story, we'll see how this happened with respect to the current, right? Now, what is the title? Transistor. What is the title? Transistor. So, N, where N is electron is the majority, and electron is majority, whereas where P is hole is majority. Okay. So transistor, the title is transistor. The function of emitter is to emit the majority carrier or electron. The function of the collector is to collect majority. The function of base is to allow the minority. Now let us say here, electron, let us say there is an electron at emitter and negatively charged, and this has to reach to top of the board, right? This has to reach to here, emitting, collecting, right? So with respect to that, I am applying negative potential, negative voltage here, which ripples the same electron. So the electron will start moving. Negative voltage which ripples. Again, with respect to negative, I also applied a 0.7 volt positive voltage. So this 0.7 volt positive voltage to the P region, which try to attract electron, and there is a voltage, normally greater voltage or less voltage, whatever. This negative voltage ripples and this positive voltage attract. Now my electron start moving. Let us assume 100 electrons start moving. 100 electrons start moving, right? Because of applied positive voltage at the base, applied negative voltage to the emitter. What is the function of emitter? emitting majority carrier. What is the function of collector? Collecting majority carrier. What is the function of base? Allows minority carrier, right? Which means the same electron when jump into this area become minority, the same electron when jump into this become, right? Now this majority carrier moving towards the junction, majority carrier moving towards the junction, right? Moving towards the junction. Then the word towards, I understand this base and emitter become forward bias. This base and emitter become forward bias because majority carrier moving. What is my responsibility? Emitter emitting electron, collector collecting electron, right? Collector, what is the role? Collector has to collect the electron, emitter release the electron, right? So that with respect to the concept, I applied a negative potential here to repel the electron, I applied positive potential here to attract the same amount of electron. Now we know according to the doping, emitter is heavily doped, so he creates or generates electron. According to this, collector is moderately doped, so he has ability to receive the same. But base is lightly thin layer, area wise is very thin, as well as by doping wise is lightly doped. So why is this lightly doped? I'll tell you. Let's say 100 electron started. What is my aim? My aim, at least this 100 electron have to reach collector, but I have to cross the junction. What is the problem? Sir, there is a lightly doped positive charges. There's a lightly doped positive charges. Once this electron reaches, mean 99 electron reaches at base, one electron become recombination, or the 100 out of 100, one electron will lose its energy because of the recombination. So one electron will divert and goes to base. 100 I've started because why 100 heavily doped? Why only one electron become recombination? Because lightly doped, and 99 electron reaches to collector, right? Remember, this is become forward bias, where this emitter pumping load of majority carrier. Why? Because of the forward bias. What is forward bias? This junction is almost approximately a thin barrier potential. Why I have made a thin barrier? Because external voltage, this 0.7 volt, makes into very thin barrier. Blue color. நீ மட்டும் நீ செருப்புலாம் எடுத்துட்டு வரவாடா, செருப்பு அங்கே இருக்கு, யார் எடுக்கணும்? உன் செருப்பு. நோட் புக் எடுத்துட்டு வாடானா செருப்பை கையில் எடுத்துட்டு வர, அங்கேயே விட்டுறது. வந்து இன்னொரு போயிட்டோம், ஏன் இவ்வளோ ஸ்லோவாக வர? டேய் நில்லுடா, கால் மேல கால் போட்டு பேசிட்டு இருக்கு. So there is a 100 electrons started from the emitter, because emitter emitting the majority carrier, collector collecting the majority carrier. One retained or recombined with the base. Why? Because it is lightly doped. Why recombination? Positive and negative attract each other and that become an ion. Or I would say one electron, this one electron is attracted by because of the positive potential. This out of 100, one electron is attracted because of the positive potential. Remember, what is the role of emitter? Emitting. What is the role of collector? To pull. What is the role? Push. The push can be done by because of the forward bias, and the same electron should be attracted. Here the same electron should be repelled. This attraction, the electron must be attracted by the positive potential given. What is positive potential to n region? This probably a reverse bias. This is the forward bias where it will try to pull the electrons, right? Pulling up. Whereas here, this will try to push all the electrons, whatever, right? Push and pull, whatever. You understand your own word, but what I'm trying to say, here under electron may start because of the repulsion. This electron also getting collected. Remember, the electron is moving away, right? This electron is moving away because it is towards, it is away. So this away represents this electron moving away. The electron is moving away. What is that? Majority moving away. That represents reverse bias. Majority moving towards, that represents forward bias. What is my idea? I have to pass 100 electron from emitter to collector. Unfortunately, one had settled at the base because of the heavy food. Got the point? Positive negative got intermingle and become iron. You know it, right? More chemistry we will understand, right? So this is the role of the transistor. You got the point? Role of the transistor. Emitter has to emit the large number of electrons. Collector has to collect large number of electrons, and base allows the minority carrier, right? Electron here is majority. The same electron here is minority. The same electron here it is the majority. Okay, this is one. Don't worry, I'll tell you what is amplifier. Convert small signal into large, right? What is that? Small into large. I'll come to you, don't worry. If there is any doubt here, okay? If there is any doubt here, I think I've not mentioned one thing, which is I think I understand, and I'll understand that you people will remember a lot. Right? What happened at the open circuit? We know it is the NPN transistor. This is NPN transistor. So there is a barrier potential, right? There is a barrier potential. You got the point? There are two barrier potential. So NP minus plus, minus plus, minus plus, minus 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 minus. Right? Minus plus. You got the point? So this is at open circuit. This is at exactly open circuit. Now I have applied some voltage, that is minus V plus V plus V. Right? Got the point? Okay. So what is happening here? Here, depletion regions become, after application of the voltage, this depletion region become narrowed down because of forward bias. And what about here? This will become widened. Why? Because of the reverse bias. Why this narrow down? Electron moving towards the junction. Why it is broadened? The same electron is moving away from the junction. When electron moving towards the junction, it will try to reduce the depletion region width. When electron moving away, it is moving away where the depletion regions become wider. Or I would say, here the majority carrier crossing the junction, here the majority carrier crossing the junction, here the majority carrier crossing the junction because it is N to P and N to P, so majority carrier crossing the junction. Same electron crossing this junction from P to N. Same electron crossing the junction from P to N. So here I would say he become a majority. The same electron here it has become minority. Okay, you got the point? Here majority because towards. The same thing become minority. What I am trying to say, this reverse bias allows minority carrier get into that. This forward bias allows majority carrier get into that. You got the point? Here I need some energy where attract all the majority carrier. Here I need some energy where ripple all the majority carrier. Okay, so to ripple, I make sure the junction 1 become forward bias. To attract, I make sure the junction 2 become reverse bias. What is reverse bias? The minority carriers are crossing the junction. What is forward bias? Majority carriers are crossing the junction. Or I would say junction J1, majority carrier moving towards the junction. At J2, minority carrier moving towards the junction. You got the point? Towards. Both are majority, minority. Both are towards. Whereas here, majority carrier towards, so become forward bias. நான் என்ன சொல்றேன், majority carrier moving away. With respect to the area, அதே electron தான்ப்பா emitterல majority, அதே electron baseல minority, அதே electron collectorல majority. You got the point? Now, yes. Now, we are here to calculate the current. What I said very clearly, 100 started, 99 have reached, 1 settled, 1 moving towards. Always remember, J.J. Thomson, he invented electron. And P.J. Thomson gives the answer for the current. What is current? I equal to dq by dt. I is equal to dq by dt. My dear students, probably another 10 to 15 minutes, I'll have end up the section. Don't worry. Ask her to the problem. You wanted to go out to refresh yourself, please go. Go and come. Not an issue. Okay. So 100. Listen. J.J. Thomson, he derived the electron activity, and P.J. Thomson, he said what is current? I equal to dq by dt. Right? Rate of change of current. Small I equal to dq by with respect to time dt. So when electron moves this direction, then what about current? What about current? Current moves this direction. Okay? So the current dq by dt move this direction. Got the point? So from the diagram, what is 100? I'm sure greater than 99. What is 100? Greater than 99. What is 1? I know 1 plus 99 is equal to 100. Okay, wow. Then collector current IE is equal to IC plus IB. Am I right? Emitter current IE equal to 100 equal to 99 plus 1. Okay? Got the point? Yes or no? Then from this collector current, I'm sure far greater than base current, right? From this collector, one is far less compared to collector, right? So collector current is far greater than compared to base current. Or collector current is equal to IE minus IB. You got the point? 100 is equal to 1 plus 99. You got it or not? Yes or no? Right? In that way. Okay, this is one way. Okay, another way to define, there are 3 parameters for transistor. Always the top priority, alpha, beta, VBE. These 3 are the parameter, important identity of transistor. Any transistor, if you go and buy any transistor, I'm sure you will ask you alpha, beta, VB. That defines all characteristics. I'll tell you how it is. Let's say in other words, one trillion electrons start from emitter. There is a alpha. 1 trillion electron may start from emitter, and only alpha electron reaches to collector. And what about this? 1 minus alpha going to base. I'll repeat. 1 trillion electron start from emitter. Alpha electron reaches to collector. Then what is the base current? 1 minus of that equal to this. You got it? Yes or no? Right? Yes or no? Yes or no? Now tell me, what is base current? Base current is nothing but 1 minus alpha. Base current is nothing but 1 minus alpha. Okay, what is emitter current? Emitter current is equal to 1. Let's say 1. What is collector current? It is equal to alpha times. What is collector current? It is equal to alpha times. Okay, now come to the point of understanding. From here, what is base current? Base current is equal to emitter current minus collector current. Emitter current minus collector current. Okay, wow. Yes. In general, alpha is equal to IE by IC, beta is equal to IC by IB. In general, alpha is equal to IC by IE, and beta equal to IE by listen. What is collector current? Collector current IC is equal to what is collector current? IC is equal to emitter current minus this. Okay, now listen. The important takeaway note is that 100 or 1 trillion or 100 electrons start from here, 99 have reached, and base equal to 1. Base is equal to 1. You remember, collector current is 99 times greater than compared to, all of you listen. Collector current is 99 times greater than compared to base current. 99 times. Yes or no? Yes or no? 100, 99, 1. You got the point? 100, 99, 1. So collector current 99 times the base current. Collector current 99 times the base current. Now come to the point of understanding. My amplifier circuit. What is this? Weak signal. For example, common emitter amplifier. Now I'm using symbol to represent. Right? This is base, collector, emitter. Emitter is common. Let us assume this is my load, right? RLC load. This is my input, right? Base is my input. Generally, base is my input, this is my output, right? So what is this? Sorry, right? What is collector current? Collector current is equal to output current is equal to this minus this, right? So my base current is my input, collector current is my output. What is my base current? 1. What is my base current? 1. What is my collector current? 99, which means minimum, I'm telling you, but roughly I'm telling you, minimally, if I pass some millivolt here, right? Some millivolt here is my signal, is my weak signal. Millivolt here, this will be transmitted 99 times greater. Got the point? 99 times greater. That's why this become a amplifier. This become a amplifier. Got the point? This become a amplifier. Got the point? Yes or no? How transistor it become an amplifier? Listen, I'm applying here base, right? What I'm applying? What I'm applying? I'm applying this my weak signal to base, right? So the base current, the base current. Listen all of you. Listen all of you. This is my base current. So it look like this. What is this? Change. What is this? Change. Audio pitch. The same change will ripple in the IB. The same thing. The IB is also dancing like the signal. IB is also dancing like the signal. Okay? And with respect to this, IC also dancing like the signal. Remember, this is my audio. This is my audio. The audio is connected to my what is my convert non-electrical quantity into electrical quantity. So when audio signal look like this, pitch will dance. Like IBs also look like dance of 1%. You see collector current, same rhythm will take place at the collector current, but 99% of amplified signal. You got the point? Yes or no? Yes or no? What is this? 1% of my dance, right? Mean harmonic dance, mean rhythmic, right? Audio rhythmic dance. This 1% change will change the 1% of the IB. That IB 1% into 99% of the collector current. The 99% of the amplified signal will deliver to the speaker. Now speaker will enhance the signal and reach you out. You got the point? So the collector current is rhythmically connected with the base because the base is connected to mic and speaker is connected to load. That's all about bipolar junction transistor. You got the point? What is bipolar junction transistor? 3 terminal, 3 layer, 2 junction device. Emitter heavily doped, collector moderately doped, base lightly doped, and very thin layer. Transistor is also called as sandwiched semiconductor device. Okay? So other detail have been given on the board.